Next we are going to study carboxylic acid's chemical properties. Okay. Okay. So this chemical properties, listen, what is carboxylic acid? The general formula is RC double bond O bond OH. Okay. So this is the general formula for acid. Okay. So this carboxylic acid chemical properties we are going to study the cleavage of the reaction due to cleavage of OH group. Okay. And the second one, the reaction due to cleavage of CO group. Okay. And the reaction due to cleavage of alkyl with carbonyl group. Finally, we are studying the reaction with alkyl group. Okay. So these are the topics we are going to study. Okay. So this is again I will write R C double bond O bond OH. Okay, this is general formula. Okay, the question is chemical properties like carboxylic acids are highly acidic in nature. Okay, so the question is in board question, why are carboxylic acids acidic in nature? Okay, so acidic in nature. Okay, so here the least one we very well know that alkyne is the least one, CH triple bond CH. So that is called the alkyne group. It is the least one, less than alcohol, less than water, less than aryl alcohol or phenol. Okay, less than COOH, less than HX. So this is a more acidic. So this more acidic, the HX, it is a HCl, HNO3, H2SO4. Okay. So these are called mineral acids. So mineral acid we may consider that is a inorganic acid. So first of all, acid, the Ka value, the mineral acids are more acidic. So apart from here we are studying the organic compounds, the carboxylic acids are acidic in nature. Okay. After that phenol after that water, then alcohol, and the least one is, this is least one. Least the acidic nature is alkyne group, hydrocarbon. Okay. So right. Here the acid group, whenever the acid group hydrolyzed with water to produce carboxylate anion plus H plus. Okay. So the removal of H plus, it shows that it is a acidic property. When a compound hydrolyzed with water to produce OH minus ion, that is a base character. Here the acidic character means it releases the H plus acidic in nature. H plus releasing of H plus ion, that is a acidic in nature. Okay. So here suppose this carboxylate anion, so it undergoes the dispersed charge, it undergoes resonatic structure. Okay, so let me write like this, C double bond O and O. Okay, this is minus charge. So when dispersed, this particular carbonyl carbon, the dispersed charge or the pi bond shifting, because of this it will the anion, the more negative element, it contain the electrons, rich electrons come forward here, and this shifted to, it undergoes resonatic structure. Okay, C double bond O, then this oxygen, it gets negative charge, and this the electron shifted to here, it gets partially double bond. Okay, so this is for resonance structure. Dispersal charges, it produces a resonance structure. So the higher the number of resonatic structure, higher would be the stable. Okay. So this carboxylate, it undergoes to produce a resonatic structure. The carboxylate anion is a resonant, for stable one. How? Because this acid group react with hydrolyzed with water to produce RCOO, carboxylate anion plus neutral, okay, H3O plus, okay. So this is conjugate acid and conjugate base, okay. This is conjugate acid and conjugate base, okay. So the conjugate base is more stable. This is key point, the conjugate acid is more stable. The corresponding acid for that, this is a more acid or stronger acid, okay. So that the produce of conjugate, which one produce the conjugate base, like carboxylate anion, the acid, carboxylic acid. So the conjugate base of the carboxylic acid, it is a conjugate acid, it is a stronger, okay. If the conjugate base is stable, that particular corresponding, the conjugate acid is a stronger acid, okay. So these are all key points, okay. So first of all, we have to prove it undergoes resonatic structure. So why it undergoes resonatic structure? Because of this carboxyl group, it dissolved with water to produce a the conjugate base and conjugate acid. The conjugate base is more stable because of due to undergoing resonatic structure, the corresponding acids also stable, okay, stronger acid, okay. So this is one key point, okay. So next one is, so we have to take the equilibrium constant Ka equal to the product of concentration of carboxylate anion and the sum of plus H plus by the reactant or COOH, okay. So this Ka is dissociation acid constant, okay. So this dissociation acid constant pKa equal to minus log Ka, okay. So the concept is higher the Ka value, lower the pKa value, stronger is the acid. Very, very important point. Stronger is the acid. Here you see, for formic acid, the Ka value is 17.2 into 10 power minus 3, okay. The pKa value is 3.16, okay. Higher the Ka value, lower the pK value, strong acid character. And ethanoic acid, that is the 17.1 into 10 power minus 3, and this is 4.16 something. So higher the Ka value, lower the pKa value, stronger is the acid. This is the second key point, okay. The third one, the presence of substituent, okay, the presence of substituent also to affect the acidic character, okay, effect of substituent. So we may know that is electron withdrawing group and electron donating group, okay. So electron withdrawing group, who is electron withdrawing group? Chlorine, NO2, nitro compound, okay. Electron donating group, methyl, ethyl, CH2, CH3, ethyl and methoxy. So these are all electron donating group, okay. Electron withdrawing group stabilize the acidic character. So it is increase the acidic character, okay. So the presence of electron withdrawing group stabilize the acidic character, so that increase the acidic character. Electron donating group destabilize the acidic character, so decrease the acidic character, okay. So I will tell you, and also the substituent, like what is the order, that is phenyl less than iodine less than bromine less than chlorine less than fluorine less than Cn minus less than NO2 minus less than fluorocarbon. Okay, 3 or 2. Okay, so this is a more acidic, this is a least one. Okay, so this and all for fluorine, the halogens are that also the acidic character, the substituent. So this is the presence of substituent in alkyl group, aryl group. This is a order. Okay, if the NO2 group is present in a alkyl or aryl group, so aryl group, so it increase the acidic character because NO2 is a kind of electron withdrawing group. Electron withdrawing group increase the acidic character. If the particular aryl ring, the CN group is present, so the CN, COOH with the CN, the CN it increase the acidic character. Okay, fluorine also increase the acidic character. Okay, so this is the order of the substituent present in alkyl or aryl group, aryl ring. Okay, right. So let me take some example. I will tell you. Suppose, so these three, listen here. This is COOH. Here the methoxy group is present. Another one compound. This is only hydrogen. This is what? Benzoic acid. Okay. Okay. This is methoxy benzoic acid. This is benzoic acid. And here you see this is acid, benzoic acid with NO2 group is present. Okay. So the effect of substituent to increase or decrease the acidic character. Here you see this is A, this is B, this is C. Okay. For NO2 group is a kind of electron withdrawing group. So electron withdrawing group stabilize the acidic character and strengthen. Stabilize means strengthen the acidic character. So increasing acidic character. Okay, increase the acid. Okay, acidic character. And electron, the methoxy, this is what? Electron donating group. So electron donating group destabilize the acidic character. So what is the answer here? This is 1. So here we have to write 1, 2, 3. Okay, so how do you write? 3 greater than 2 greater than the least one. Least character is because of electron donating group. Okay, this is your answer. Okay, so like that. So we studied 3 characters. What are they? The resonatic structure. So when the resonance should be stable to produce a strong conjugate base, so that particular acid will be a resonance or stable, and higher the Ka value, lower the pK, stronger is the acid, and in the presence of substituent also to determine the increase or decrease the acidic character. Okay, so that only, listen. Okay, students, listen. The reaction with metals, it proves, these reactions proves the acid, the carboxylic acid is a highly acidic in nature because of. So what is the metals, highly reactive metals? Highly reactive metals means the reactivity series we studied in our electrochemical series. The hydrogen above some elements are present. Okay, so what are the elements present? Lead and iron, then zinc. So like that the elements are present. Okay, so hydrogen below some elements are present. Copper and silver and gold and platinum, like. Okay, so below, so the above present, the hydrogen above presence of elements are highly reactive elements. So highly reactive. This is the one element, the elements which are present below, that is are least elements. Okay, least reactivity or less reactivity, not use least, less reactivity. Okay, so why it is a less reactivity? Because these elements do not react with acids. So okay, but the above, which the elements which are present above, it react with acids. Okay, so that is called the presence of above elements or highly reactive elements. Okay, so here The highly reactive elements like sodium react with carboxylic acid to produce carboxylate plus H2 gas, okay, and hydrogen. Because of it react with highly reactive element with acid to produce release H plus. So this released H plus, it shows that it is a strong acid, okay. At the same time, for carboxylic acid react with the sodium hydroxide to produce water, okay, salt plus water, and sodium bicarbonate, it produce water plus CO2, okay. So students sometimes will ask you, carboxylic acid with sodium, it is only the release of H2, carboxylic acid with sodium hydroxide alkali to produce salt plus water, carboxylic acid with sodium bicarbonate, it is salt plus water plus CO2, okay. So this the releasing of H2, it is the acid, stronger acid. The releasing of CO2, it is the stronger acid, okay. A reaction involving cleavage of COH, okay. So COH bond, okay. So here that is ethanoic acid, okay. The two similar ethanoic acid, what is that reaction? Cleavage of COH bond, okay. So cleavage of COH bond, the acid carboxylic acid react with in the presence of sulfuric acid and phosphorus pentoxide, to the water molecule is removed, okay, water molecule, because cleavage of COH bond, water molecule is removed to form CH3. Sorry, let me take this one. CH3, listen, CH3, C double bond O, and here that is listen, double bond O, and here that is CH3, okay. So this is ethanoic anhydride, ethanoic, because what is that formula? CH2, here two molecules, no, so 2CH3 COO twice, that is ethanoic anhydride, okay. So ethanoic acid, it undergoes the cleavage of OH bond to produce ethanoic anhydride, okay. The next one is esterification. So it is very important in our, we are going to do for esterification reaction, because you have acid group or alcohol group. This is one of the test, esterification reactions, okay. So acid and alcohol react with in the presence of corn sulfuric acid and or HCl gas to produce ester. It is a fruity smell, okay, or COO or prime plus H2O, removal of water, okay. This is ester, it is a fruity smell, good odor, okay. And reaction with PCl3 and PCl5 and SOCl2 means dionyl chloride, okay. So students, you see this carboxyl group, the presence of, listen, this is C double bond O and OH, okay. So both carbonyl group as well as hydroxyl group, it represent, it is alcohol, okay. So the presence of OH group is present, the carboxyl acid, so it behaves like a alcohol. So in alcohol chapter we studied, no, alcohols react with phosphorus pentachloride, trichloride and dionyl chloride. So here also this presence of OH hydroxyl group, it behave like alcohol to react with phosphorus pentachloride to form acid chloride, alkyl acid chloride plus phosphoryl chloride, POCl3 plus HCl, okay. So 3 unit of the acid means that is 3 RCOCl, that is acid chloride plus H3PO3, that is phosphorus acid, okay. The reaction with dionyl chloride, the same we studied in alcohol, the reaction with dionyl chloride, what is that? The same acid chloride plus SO2 plus HCl, okay. Because of the presence of OH behave like a alcohol, so react with trichloride, pentachloride and dionyl chloride, okay. Next one, reaction with ammonia. Okay, so the carboxylic acid react with ammonia to produce ammonium salt. Okay, for example, CH3COO, this is ammonium salt to produce NH4 plus. Okay, ammonium salt. So this ammonium salt, that is ammonium acetate, this ammonium acetate react with the high heating to removal of water to produce acetamide, CH3CONH2. Okay, this is acetamide. Okay, and same thing here, first of all produce COO NH4 plus. Okay, after removing water molecule for heating to produce benzamide. Okay, benzamide CO NH2 or else C double bond O NH2 benzamide. Okay, so this is what benzamide. Okay, the next, the same, the acid react with water to produce COO NH4 plus, COO NH4 plus. So this react to produce phthalimide, CO. So how do you write CONH2? Same thing, CONH2. So during strong heating, ammonia molecule gets out and to form phthalimide. Okay, CO or else write CO, that is CO and NH. Okay, phthalimide. Okay, right. So this is for reaction with ammonia. Okay, for reaction with ammonia, acid produce amide. Okay, that is, keep it in your mind, acid produce amide. Okay, and reaction involving COOH group. So we studied carboxylic acid reduced with lithium aluminum hydride to form primary alcohol. Okay, to form primary, this particular COOH acid group, in the presence of strong reducing agent, it gets reduced to produce primary alcohol. Okay, so this is a diboron and sodium hydroboride. So this and all reducing agent, but for this case carboxyl, you keep it in your mind, this is one more question. For carboxylic acid group, actually it is a reducing agent, but in carboxylic acid group it is not reduce easier. Okay, so only we have to use lithium aluminum hydride. In the presence of lithium aluminum hydride reducing agent, the carboxylic acid group reduced to produce primary alcohol. Okay, so decarboxylation means that is removal of CO2. Decarboxylation means removal of CO2. Okay, for this alkyl salt in the presence of NaOH and CaO, this is soda lime. Okay, the mixture of soda lime, that is 3:1. Okay, and the mixture of soda lime, in the mixture of soda lime, the alkali sodium salt react to produce hydride. Okay, hydride plus carbonate salt. Okay, so this hydride and this is called electrolytic Wolff electrolysis. Okay, another name it is decarboxylation. So why it is decarboxylation? Because of removal of CO2 in the presence of soda lime, the alkali sodium salt remove CO2 gas and to produce a hydrocarbon. So the another name is called Wolff electrolysis method. Okay, and the last one, substitution reaction in the hydrocarbon part. Okay, so here you see the acid groups contain alpha hydrogen atom. Okay, so this is whenever the functional group, the nearest carbon atom, we may consider this is a alpha hydrogen atom containing alpha carbon. Okay, so alpha, the hydrogen, the carboxylic acid containing carboxylic acid react with halogens in the presence of red phosphorus to form in the hydrolysis reactions to form alpha halic acid, because the halogens, the X, it may be chlorine or bromine. Okay, so this to produce alpha halic acid, because this halogens with bonded with alpha position. So what you get are CH bond X COOH. Okay, so the halogenated bonded with alpha position, so that is alpha halogenated atom, alpha halogenated acid. Okay, so this is called Hell-Volhold-Zielinski reaction. Okay, what is Hell-Volhold-Zielinski reactions? Alpha the carboxylic acid, it contains alpha hydrogen atom. So in the presence of halogens with red phosphorus, the halogens bonded with alpha position like hydrogen, so that is called alpha halic acid, because of this is halogen. Okay, so this is called Hell-Volhold-Zielinski reaction. And the ring substitution, the last one, this is the carboxylic acids, aromatic carboxylic acid, this is benzoic acid, no, aromatic carboxylic acid act as a it undergoes electrophilic substitution reactions. Okay, so because of carboxylic acid, the anion is a deactivating and meta directing group. Okay, this is carboxylic group act as deactivating and meta directing group. Okay, so here the presence of nitric mixture, it produce NO2. Okay, electrophile produce NO2. So what you get? Nitrobenzoic acid. Okay, NO2, because of this is meta directing group, no, so that is NO2. Okay, meta directing group, so meta nitrobenzoic acid, meta nitrobenzoic acid, benzoic acid. Okay, so here also to produce bromine. Okay, so it form, that is COOH, and meta position, because deactivating and meta directing group, so meta bromobenzoic acid. Okay, so here students, one question will ask you, why the aromatic acids do not undergo Friedel-Crafts reactions. Okay, so this aromatic acids, it do not undergo Friedel-Crafts reaction because of what is the characters, that is a deactivating and meta directing group. For that reason only, so it do not aromatic, especially aromatic acid, it do not undergoes Friedel-Crafts reaction. Okay.